Hi everyone, my name is Dr. Ramkrishna Hegde. Here I have referred some of the materials directly from data communication networking my course on in this lecture. Today let's discuss about media access control. Under that, one of the very important method really called a controlled access. See, in reality, what happens? Many devices, let me put it as many stations are connected or maybe communicate over the single channel, right? During this case, what happens? There is a chances of collision of frames. To avoid this collision of frames, one of the very important method we need to discuss today is a controlled access. Now let us see what is this controlled access is all about. In a controlled access, the stations consult one another to find a station to find which station has a right to set. Every station will be assigned with the rights. The particular station can able to send or not. That is something we call as a right here. A station cannot send unless it has been authorized by other stations. We discuss in this particular case, there are three very important methods here. One is called reservation, second one is a polling, third one is a token passing. We'll see what is this reservation access method is all about. In reservation access method, a station needs to make a reservation before sending the data. See here what happened, the time is divided into intervals. Each interval, a reservation frame precedes the data frames sent in that interval. If there are n stations, then in a system, then there is exactly n number of reservation mini slots in the reservation frame. There is one separate frame is called a reservation frame. This reservation frame actually divided into mini slots. That all depends on how many number of stations. For example, if n number of stations are there, then reservation frames are the intervals is divided into 5 mini slots, and every individual mini slots are assigned to what is that? Assigned to individual stations. You can see this. Each mini slot belongs to a station. When a station needs to send a data frame, it makes a reservation in its own mini slots. In own mini slots. If you can see this particular figure, then you can able to understand what is the meaning of reservation here. See, whatever you can see, this is what the reservation frame. This is the reservation frame, and this is the reservation frame. Let us take this is the first reservation, first interval. Let us assume that this is the first interval. Okay. Here, what happens? You see, in this case, we have taken there are 5 stations here. There are 5 stations we have taken it. The 5 stations in the sense it should have the interval supposed to have the reservation frames should have to divide it into 5 mini slots. That means every mini slot will be assigned to every individual assigned to individual stations. Now, since there are 5 devices, or maybe stations are used here, divided into intervals are divided into 5 mini slots, right? During first interval, you can see this is the first interval. During this first interval, what happens? You are actually there are 3 stations are assigned here: data station 1, data station there is station 3, and station 4. There are 3 stations are assigned with the reservation here is reserved it, right? Station 1, station 3, and station 4, right? 3 are reserved here. Reservation is done. During the second interval, what happens? There are only one station. There is a station 1 is reserved here. Station 1 is reserved in this case, right? So that is the reason why. So in the first interval, 3 stations can able to send the data one after the other. Okay, right will be given. Then what happens here? Even if 3 stations are given, 3 stations are given a reservation here, but only one station can able to send the data at a time. Only one station can able to send the data at a time. That means it actually avoids the collision here. It avoids the collisions here. In the second interval, you can see only station 1 is reserved here, so that only station 1 can able to send the frame here. So there are absolutely no collision at all. This is what actually meaning of reservation access method. Okay. Now, second case, second one is a very important one. It's called a polling. Now, what is this polling actually? The polling works with topologies in which one device is designated as a primary station. One device is designated as a primary station, or maybe we'll call it a master station. Okay, primary station or a master station, and other devices are secondary stations. For example, you have 10 stations. Out of 10, one station normally designated as a primary station, or primary station or a master station, and remaining 9 stations normally classified as secondary stations. Now, all the data exchange must be made through primary device only or primary station only. All the data exchange must be made through primary device only or primary station only. The primary device controls the link. See, the primary or the master device is controls complete link. The secondary device follow the instructions on this. It is up to the primary device to choose which secondary device to send the data. It is up to the primary device to choose which secondary device send the data. Therefore, primary device is always the initiator in all the sessions. That is the reason why primary device is always an initiator in all the sessions. Okay. So if you look into this, if you look into this particular figure here, okay. If you look into this particular figure here, then I'll just show you this. If you look into this particular figure, there are how many stations here? There are 2 stations in this case. Okay, this is a primary. Here also there are 2 stations here, right? And if primary wants to receive the data, see, there are 2 things you need to know here. There are 2 very important words you're supposed to know. One is a select frame. One of the frame is called select frame. Another one frame we will call it as poll frame. Okay, select and poll. There are 2 things here. SEL, right? Select and poll. Now, what is the meaning of select? See, select is if the primary wants to receive data. Okay, if the primary see the select frame, what happens if primary wants to send the data? This case, what happens if the primary wants to send the data? It tells the secondary to get ready to receive the data. Okay, suppose primary wants to send the data, it tells the secondary to ready to receive the data. That means it actually generates the frame called select, and part of the select actually which contains the address of the secondary devices also. You can see select, the primary wants to send the data here. It tells the secondary devices. For example, in this case, what happens, right? Primary wants to send the data. It generates the select frame here. The select frame contains the address of the secondary device also. This case, what happens? Station B. It actually tells the station B to receive be ready to receive the data. Now, what the station B is supposed to do? The station B is supposed to, once it's received the select frame, it should have to send an acknowledgement back to the primary here. You can see this acknowledgement is sent back to the primary here. Right? Now, once the acknowledgement received from primary is received from the secondary devices, station B, what actually does? It starts sending the data. You can see here in this case, it receives an acknowledgement. Once it receives the acknowledgement, right, it starts sending the data. Once the data is sent, the B is received successfully. Okay, the B station, this case is the B station, is the destination station here. Destination station B should have to send an acknowledgement back to the primary station saying that whatever the data you have sent it, we have received successfully. That is what you're supposed to do it in the station B. Station B is supposed to do it. Now, once the station primary station is received acknowledgement from station B, right? That means whatever the data is supposed to send, that is reached destination station successfully. This is what normally call it as a selective. Very important one is a selective frame, right? It generates a selective frame whenever the primary wants to send the data. Okay. Another very important one you can see in this particular figure is called poll frame. This is what whenever if the primary wants to receive the data. This case, what happens whenever the primary wants to receive the data, it asks the secondary devices, okay, if they have any things to send, right? In a polling, what happens if the primary wants to receive the data? It asks the secondary devices. It asks the many, there are many secondary devices, right? It asks the secondary devices if they have any things to send, right? This is exactly called it as poll. If primary wants to receive the data, right? It asks the secondary devices if they have anything to send. This is where we'll call it as a poll. See, if you take this particular example, right? Primary, this is a primary station, right? It actually sends the it actually the primary wants to receive the data. It sends the pole frame here. It generates a pole frame. Okay, sent to station number one. The part of the pole frame will contains the address of the station, the destination address, right? The address of the destination station, address of the destination station. So pole frame actually go to a what is the station B. Now what actually the station B does? It no data to be sent in the station B, right? Sorry, station A. In the station A, no data to be sent here. That is why station A sends the negative acknowledgement to primary here. You can see NAK. This is the negative acknowledgement. Now, whenever the primary receives the negative acknowledgement from the station, it thinks that no data to be sent from that particular station. So immediately what it does, it generates the pole again. That pole is sent to what? Another station, right? Another station in this case is what? Station B, right? This pole contains the address of the station B here, right? Now the pole is reached to station B. Now, what the station B does, suppose it is having a data to be sent, then it should have to send a, directly it transmits the data here. It directly transfers the data. In this case, what happened? There is a data to be sent in the station B. There is a data to be sent in the station B. Now it receives the pole, right, from primary. So immediately after receiving the pole, it sends the data to primary station. It sends the data to a primary station. Now, whenever the primary station receives the data, it should have to send an acknowledgement back to the station B, right? Suppose if it receives the data successfully, then primary station should have to send an acknowledgement to the station B. Here, this ACK, this is a positive acknowledgement. Whenever it sends a positive acknowledgement, okay, to station B, that means that means the primary station is received the data successfully, right? This is what the meaning of poll here. There are two very important things you need to know when it comes to polling here. One is a select, another one is a poll, right? Select in the sense whenever it wants to, whenever the primary wants to send the data, it tells the secondary station be ready. That is a selective. The poll is something about whenever the primary wants to receive the data, is ask the secondary devices if they have any data to be sent. That is the meaning of poll. Okay, this is a very important method when it comes to control access. Now let's move on to other one. Let us move on to other one. Okay. Let us move on to other one. It's called what is that? Ring. Okay. Another very important one called as a token ring, right? Token ring here. In token ring, what happens? In token ring, the station in the network is organized into logical ring here. Okay. In token ring, what happens? The token ring passing, the station in the network is organized in a logical ring. That means for each station, there is a predecessor and a successor. The predecessor is a station which is logically before the station in the ring. The successor is a station which is logically after the station in the ring. After the station in the ring. Okay. The current station is the station is the one that is accessing the channel right now. Current station is the one that is accessing the channel right now. The right to this access has been passed from the predecessor to the current station, right? This is how normally happens. That means how do you see the access to the channel should be passed from one station to another station, right? What happens usually, the right to this access has been passed from predecessor to the current station initially. The right will be passed to the successor when the current station has no more data to be sent. No more data to be sent. So in this method, what happens? Special packet is called token is circulated among the ring. What happens here, as I mentioning again and again, there is a right will be assigned to every station, right? But the thing is, how do you assign the or maybe access right of the channel to the different station to station? How do you pass the access right from station to station, right? This is where we come up with a special packet. This is where we come up with a special packet we call a token. Okay, it's called a token here. This is actually circulates through the ring. The possession of the token ring gives the station to access the channel and sends its data. When the station no more data to send, it releases the token. When the station no more of data to be sent, it releases the token immediately. Right? See, one of the very important one here is a token management. Okay, one of the very important one is a token management also here. The token management what actually does. See, first of all, let us take one scenario. Suppose the token is circulated among the stations, different stations. Now, one of the station is acquired that particular token. Okay, acquire the particular token, and it fails to transmit the data. It holds the token, but it fails. What happens there? The station holds the particular token but fails. That means the particular token is what? Destroyed. The particular token is destroyed. Now, once it's destroyed the particular token, what happens normally? Other station will not receive the tokens. Will not receive the token, right? The token management, what actually does, it monitors all those things. Suppose if it is destroyed in between, what happens? It regenerates the token and sends to the resends the token, right? Now, here what happens? See, it assigns the token to a other station. Now, other station can also receive the token here. Now, another very important functionality of the token management is prioritizing the stations and prioritizing the which type of data to be sent. Now, imagine low priority stations holds the token. Okay, low priority stations holds the token, but there is a highest priority stations are waiting for the token. What it's supposed to do? That case, what happens? That token management is supposed to do? It should have to tell the low priority stations to release the token, because there are high priority stations are waiting for the tokens here. Now, token management tells the low priority stations to release the token and sends to the high priority stations, so that high priority station can able to access the link and can able to send the data, right? This is what another functionality of the token management. Now, when it comes to token management, we always here what happens there, between the stations you should have to form the rings here. Okay, should have to form the rings. Now, when I say rings is going to be a logical ring with the help of physical topology. Actually, it forms a logical ring here. You can see there are four ring topologies you can see here. First case is a physical ring. Physical ring, what happens is a simple method where if you see this example, there are four stations here. These four stations are connected physically with the help of a cable, connected physically. You can see this, right? You can see here station 1, station 2, station 3, and station 4. The station 1 should have to have a address of the successor station, right? What is the successor station for station 1 here? Is a 2 is a successor station for station 1. Now, station 1 should have to send should have to have a address of the successor station. That means in this case is station 2. So other station no need to know, like that whatever the station 1 no need to know the address of the other station. Okay, the station 1 should know only the successor station address. That's it. So here it sends the token here. It sends token. This forms a ring. Okay, the same process continues in other cases also. Same process will continues in other process also. But one of the demerits here, maybe a difficulty you can see here. Suppose in between any one of the station, if the link is broken down, okay, if the physical link is broken down, what happens? Whole system will get collapsed, right? If the physical link is broken down between any one of the two systems here, the whole system will collapse here. It will not work. That is the problem with the physical ring here in this case. Now let us move to another very important one. Is called a dual ring. Dual ring, what happens? There are two rings of top. This is the initial ring. You can see it's a normal physical ring. This is the same physical ring. This is the first one, physical ring here, right? This is the second ring. You can see this. This is what we'll call it as a second ring here. First ring, what happens is ring 1. Okay, station 1, go to station 2, then station 3, station 4, and it comes back to station 1. This is the first ring. Now the second ring starts from station 1. Okay, is a reverse of it. You can see this 1 to 4, then 4 to 3, 3 to 2, and 2 to 1. This is the second station. That means it uses secondary ring. We actually call it as secondary ring. We actually call it as auxiliary, which operates in the reverse direction. The secondary ring, this actually operates in the reverse direction. You can see this, right? This secondary ring normally call it as an auxiliary. The secondary ring is actually used for emergency purpose only. When I say it's an emergency purpose, what happens? Suppose this primary ring, the first ring which is there, if it is failed, suppose between any one of the stations, some physical connection is broken down. What happens? The secondary station will act now. Auxiliary station will act now. What happens is the auxiliary station will build the connection between the two rings here, between the two stations, and it connects now. Now the ring is formed, right? So whenever the ring is formed, so it's become normal. Okay, now proper connection is exist between different stations. Now actual ring is formed here. Now auxiliary station is become what? Idle now, because the work is done, right? Because what happens, if the primary ring, if one of the connection is some broken down, what happens? The secondary ring acts immediately, right? It starts building connection between the wherever is broken down. It again builds the connection between the two stations, right? So that the connection is exist as normal now, right? When it is become normal, the auxiliary ring will become idle, will become an idle. Okay, this is how the dual ring things will work. Here one of an advantage you can see, even if the primary rings fails, still it can able to transmit the data, right? It can able to transmit the data, right? And some of an application like high speed token ring network, for example, like FDDI, we'll call it as fiber distributed data interface. And another very important high-speed token ring network is the CDDI, copper distributed data interface. In these two applications, normally there's ring topologies, okay, normally used. Now let's move on to another maybe topics here. Okay, that is before moving on to before ending the slide here, let us see this. What is this? What is that bus ring topology here? Okay, you can see one more. See, we have finished here dual ring, right? Now let us come back to the bus ring here. Bus ring, what happens in the topology? The token bus LAN. Okay, example for the bus ring here. This is a token bus LAN. Here, what happens? This is every station is connected with a single channel here, single cable here, right? Single cable is connected here. That means what happens here? The single channel, it builds the logical ring here, right? Between two stations, you can see this 1 and 4. These two stations are connected by a single channel. So this is logically built here, so that the rings can be these rings can be formed, and the data can be transmitted among this, right? Some of an example for the ring topologies are the token bus LAN, standard as IEEE, uses this topology, actually, bus ring topology. Okay. So the last one we need to discuss is a star ring here. Star ring, the name itself indicates, that the meaning of the star is every individual station can connect with other station with the help of a hub here. You can see this, right? There is a hub here. That means, see, the stations are connected with the help of a hub. Hub is nothing but a connector here. Hub acts as a connector in this particular case. Now, the wiring inside the hub, makes the ring here. The stations are connected to this ring through the two wire connections here, right? That whatever the wire connection is there in the hub, that is actually makes the ring here, right? Now this topology makes the network less prone to the failure, right? This topology which actually makes the network less prone to the failure. The reason is simple, because if any one of the link is broken down, what happens? It can pass to other link here. It can pass to other path. This is what normally does in the hub, right? Star link. If any one of the link is broken down, it can send to other path. There may be other path to the station, right? So that it is less prone to failure. Also, adding and removing the stations become easy in this case. Suppose you wanted to add and remove some of the station, it is become easy when it comes to star ring topologies. And this topology is still used in token ring LAN, okay, which is designed by the IBR. Okay, this star ring topology still actually we are using in token ring LAN, which is actually designed by the IBM. So this is how this logical ring and physical topology token ring access method. There are four ring topologies here. One is a physical ring, right? Second one is a dual ring. Third one is the bus ring, and the fourth one is the star ring. So thank you very much for watching my video. If you have any doubts or any clarification, you can comment me, or maybe comment. You can send any information to me through email. Thank you very much once again watching my video.